How do we know if two triangles are similar? From the last video, we know that in general, if you want to show two figures are similar, then you need to show they have congruent corresponding angles and their corresponding sides are proportional. For example here, if you want to show these two quadrilaterals are similar, then you need to show that they have congruent corresponding angles and their corresponding sides are proportional. However, in triangles, we do have a shortcut. Today, we are going to introduce the three theorems that we can apply to show the two triangles are similar. And the first one here is called AA similarity. And the A here refers to the angle. And it says if two angles in one triangle are congruent to two angles in the other triangle, then we say these two triangles are similar. For example, in the first diagram here, if you have this angle congruent to this one and this angle congruent to this one, then these two triangles are similar by AA similarity. And some students might be wondering, okay, why is AA? It's not AAA similarity since there are three angles in one triangle. Actually, the AAA similarity sounds a little bit redundant because we know the three angles in one triangle add up to 180. So if we make sure we have two pairs of congruent angles, which means this angle congruent to this one and this angle congruent to this one, then the third pair must be congruent. So AA similarity is good. And another thing that I want to emphasize is that this theorem can only be applied in triangles. In other polygons, let's say for the quadrilaterals, like in this example here, if you want to show they are similar, then you do need to show these two aspects. You cannot just say that, okay, because their corresponding angles are congruent, then they must be similar. No, for quadrilaterals, for pentagons, for other polygons, you cannot just do that. You do need to show these two aspects. And AA similarity, that is only for the triangles. The second one here is called side angle side similarity. And this theorem says that if two sides in one triangle are proportional to the two sides in the other triangle, and their included angles are congruent, then these two triangles are similar. For example, in the second diagram here, if you have the ratio of this side and this side is equal to the ratio of this side and this side, also their included angles are congruent, then we say these two triangles are similar by SAS similarity. And I would like to give a nickname to this theorem. I would like to call this as sandwich theorem because as you can imagine, the two sides are like the two pieces of the bread and the angle here like the meat in the middle, which means that if you can make sure, okay, now these two sides are proportional to these two sides, which means that they have the same ratio, and the included angles are congruent, then these two triangles are similar. So sometimes I call the SAS similarity as the sandwich theorem. But in the exam, please do not write the sandwich theorem, just write SAS similarity. And the last one here is called a side-side-side similarity. And it says if the three sides in one triangle are proportional to the three sides in the other triangle, then these two triangles are similar, which means that if the ratio of these two sides is equal to the ratio of these two sides and equal to the ratio of these two sides, then we say the three sides in the big triangle are proportional to the three sides in this small triangle. Then they are similar by side-side-side similarity. Now let's look at some examples. Here in each diagram, write the theorem that can prove the two triangles are similar. If they are not similar, then write NA. In the first diagram, the two arrows indicate that these two lines are parallel. So you have these two angles are congruent and these two angles are congruent. The reason is if lines are parallel, then the alternate interior angles are congruent. And therefore, according to the AA similarity, we know these two triangles are similar. And in the second diagram, as we can see here, the lengths of all the sides are given. So we do need to calculate the ratios and see if side-side-side similarity works for that. But when you calculate the ratios, you need to be careful of which side corresponds to which side. Some students would make the mistake in like this, and they would calculate, okay, so 12 over 4, and that is equal to 3, and 10 over 5, that is equal to 2. Since 3 is not equal to 2, so the sides are not proportional, so they jumped into the conclusion that these two triangles are not similar. The problem is the 12 is the longest side in the big triangle, and the 4 is the shortest side in the small triangle. So these two sides, they cannot be corresponding to each other. So you shouldn't calculate the ratio of these two sides. So here you can remember the tip. You calculate the ratio for the longest size, and then for the shortest size, and then for the sides in the middle. So let me simplify this diagram. As we can see here, the 12 is the longest side in the big triangle, and the 6 is the longest side in the small triangle. So you calculate the ratio of these two sides. 12 over 6 is equal to 2. And the 8 is the shortest side. 4 is the shortest side. So 8 over 4 is equal to 2. And then the sides in the middle, you have 10 and 5. 10 over 5 is equal to 2 as well. And therefore, you can see the three sides in the big triangle are proportional to the three sides in the small triangle. They have the same ratio. So we say, according to the side-side-side similarity, these two triangles are similar. And then in the third diagram, you can notice these two triangles, they have a common angle. And the two sides in the small triangle are 9 and 12. And the two sides in the big triangle are 3 plus 9, 12. And 4 plus 12, 16. Again, the shorter side is corresponding to the shorter side. The longer side is corresponding to the longer side. So you do need to calculate the ratio of these two sides and then these two sides. 9 over 12 here is equal to 3 over 4 after being simplified. And then 12 over 16 is equal to, you can divide 4 on the top and bottom, and that is equal to 3 over 4. So these sides are proportional. And 9 is corresponding to 12, so it is this side that is corresponding to this side. And 12 is corresponding to 16. So sides are proportional and their included angles are congruent because this is a common angle. Then according to the side angle side similarity, the sandwich theorem. So these two triangles, they are similar. Okay, thank you for watching. In the next video, we are going to look at more practice. I will see you next time.